Hi, this is Catherine Skinner of the Educopia Institute. This workshop recording and all of its accompanying material is openly and freely available as part of a research project undertaken by the Educopia Institute in partnership with Carnegie Mellon University, Colorado State University, Indiana State University, the Morehouse School of Medicine, Oregon State University, Penn State University, Purdue University, University of Louisville, the University of North Texas, the University of Tennessee at Knoxville, and Virginia Tech University. It has been generously funded by the Institute of Museum and Library Services. This workshop has been designed to provide you with resources and tools to help you know how to handle data organization. This workshop is part of a 6-workshop series on topics related to the preservation and curation of research data and complex digital objects. You can access these workshops and their accompanying briefs, guidance briefs, and handouts, as well as this slide deck at https://educopia.org/research/ETD+, as you see on your screen. So by way of more context for this workshop, a decade ago, electronic theses and dissertations used to be PDFs. But increasingly today, students report that non-PDF files are just as important or are more important research outputs and evidence. So with that said, how do you make sure that your non-PDF research outputs are organized in ways that ensure their later accessibility and potential use? And how do you make sure that your research outputs are also described adequately for you or for others to make sense of your variables and other characteristics in the future? As you develop your research, you will have to consider how to manage and organize the data that you're gathering. The type of research you're doing and the standards of your field are going to affect your data organization and analysis practices. So when you prepare and submit your final work as a thesis or dissertation, earlier decisions that you've made about how your data is structured and organized are going to have implications for how readily others will be able to access and make use of or sense of your data. So in this workshop, we want to make sure that we convey to you several things. So we want you to understand some of the options that you have for data management and data organization. We also want to provide you with exposure to some of the techniques and resources that you can use to ensure that your data will be readable and understandable in the future. We also want you to understand where you can look for field-specific analysis methods, for services, for tools, and even for repositories. And just a quick note on that last piece, each field has specific methods of analysis as well as software tools that have been developed to help researchers accomplish it. They also have different repositories in many cases that make possible its deposit, its preservation, and its long-term support. And we will be covering some of those in the context of this workshop. We'll also be providing you with a lot of links to deeper material where you can get a deeper dive into this topical area after this initial introduction to it. So the key takeaway from today's workshop is that the decisions that you make about how you organize and structure your data today are going to have implications for how you and others can access and make use of it in the future. So whether you are at the very beginning of your graduate career and are just starting to play around with different file types and different research ideas and different research project spaces, or whether you're a seasoned researcher in a postdoc or in a faculty position, ultimately the decisions that you're making are A, building habits that you're going to continue to reinforce, and B, they really are organizing and structuring your content in ways that either make it easier to use or harder to use in the future. So what do I mean by that? Data is hard to deal with for a number of reasons. And particularly data that doesn't have good data documentation is often impossible to understand. So if you have a data set that has either become divorced from its data dictionary or never had one to begin with, then 10 years from the time that it was created or 20 years from the time that it was created, good luck figuring out exactly what those different variables mean unless you were the PI or the researcher that created it. And even then, many times, your memory will not hold all of those details that you wish it did. Another thing that makes data really hard to deal with has to do with how you access it. So without access to specific and often expensive software, a data file may ultimately be unable to be viewed or used years in the future. And so having good documentation about what software you need in order to render your files is one of the key components that you need to make sure that you've got in your data dictionaries and your readme files and in other materials that you provide that are part of your data organization. IRB and funder requirements can also impact the way that you need to structure your data. And so in addition to the ways that your institution expects you to do it or the ways that you've habituated yourself to do it, you're going to have to be able to adjust and be flexible to a variety of ever-changing standards within your field. And so you need to know where to go at any given moment to find the best information about how you can structure your data in order to be as successful as possible. And then finally, as data usage increases, data often needs to be interoperable in order to enable its sharing and its reuse. So it's not enough just to create a data set that is kind of your perfect data set about a particular topic that you're researching. If that data set doesn't use variables that are used commonly within your field, then you're missing the opportunity to make it possible for you to bring that data set into conversation with other data sets that may be important for understanding the broad topics that you or other researchers are interested in. So let's think for just a moment about one of the key research files that a student is likely to produce during graduate school work. And that might be your thesis or dissertation. It may be a data set. So I want you to think for a moment about where and how you'll be storing that file. So let's say that your most important research is contained in an SPSS file. What are the threats to its usefulness in 10 years? One of those threats is that you could misinterpret or not recall the full details of a variable within the file, or you could forget its relationship to other files in the future unless you have a data dictionary or readme file that describes all of the elements of your data set and any additional relationships that may exist between your data set and other files. A second threat to its usefulness is that the file itself may not be able to be rendered or opened by you in the future. Now, that may be because you no longer have access to the software package that you used. So, for example, SPSS, it's an expensive file type in terms of the software that's needed to render it. And so if you haven't saved off your SPSS data in other formats that you can access without that program, you may not be able to access your file itself after you've graduated. Particularly if you're not on the tenure track at a research institution, this may happen. You also may find that you're unable to open it because of backwards compatibility issues. So CAD, for example, which is heavily used in engineering and architecture, it's notorious for not having good backwards compatibility. And so many files will become obsolete over time, even if the software package itself is available, just because of all the changes that happen to the software and the operating system over time. The third threat is that the file could become corrupted or altered over time. So particularly if you don't have sole custody of the file, if it's a shared data set that's produced in a lab, for example, you may not know if the file is accurate. So as a researcher, there are a set of questions that you need to ask yourself and ask yourself again and ask yourself again as you're doing your work. So these questions really should be considered first at the planning stage, again, as you are actually gathering your data and storing your data, and then at least once more prior to the final deposit of your data into a digital archive or a repository, whether that's as part of your ETD or whether that's a larger deposit, either alongside a journal or in a field-based repository like ICPSR and others that we'll describe in a couple of slides. So the first of these is what are the data organization standards for your field? So for example, there are often standards for labeling data fields that will make your data machine readable, and machine readable in the context of your field in a way that is conversant with other files that are also being created in your field. There may also be specific variables and coding guidelines that you can use that will help to make your work more interoperable with other data sets. And then finally, there may be accepted hierarchies and directory structures in your discipline that you'll be able to build upon. Now, a second question that you should be asking yourself repeatedly is what are the data export options in the software that you're using. So particularly if you're using proprietary or highly specialized software to analyze large data sets, you're going to want to export the data in a format that's likely to be supported in the future and that's likely to be accessible from other software programs. And this usually means choosing an open format. So those open formats may be created by a big corporation like Adobe PDF. PDF is an open format in the sense that the Adobe has made available the specifications that govern that file format so that others can create software that can render that file format accurately. And so even though it's a company, it is provided as an open format. And so some formats are open, some formats are proprietary and closed. And knowing that you may not have access to the same software in the future and that not all software upgrades can read old file types, you're going to want to pay close attention to a set of resources that are referenced both later in this presentation and then also in some of the other workshops that you'll find in the main repository where we've stored these 6 workshops that I mentioned on the second slide. And those include 2 resources from the Library of Congress that are around recommended file formats. The third thing that you need to be asking yourself is what forms of the data will be needed for future access? So consider the various forms that the data may take and the scale of the data that may be involved. You may need to preserve not only the underlying raw data, but also the resulting analyses that you've created from it. So what happens if you do structure your data well? If you habituate yourself to do good data structuring, you're going to increase the reproducibility of your results, which is key for success in any research environment. You're also going to make it easier to reuse your own data in the future and to make it possible for others to reuse it through sharing. Through those 3 things and through just general well-structured data, you're going to gain and retain credibility because people are going to be able to reproduce your results. They're going to be able to understand your data dictionary and understand what your variables are and what they mean and partner those with things that they've created, which increases their use, which also increases your visibility as a researcher. Finally, if you structure your data well, it should enable you to be more compliant with IRB, Institutional Review Board, and funder requirements, even as those shift over time. So being mindful about the structure of your data is going to make it easier for you to make the changes that need to be made for specific funders or for specific IRBs. So what do you need to document about your data? What kinds of context do you need to provide for your data as you are working through your initial deposit of data? So some of the things that you want to document include the data's purpose and a list of files that are there in your data package. And so I'm including here an example README file that came from DataAb Initio. And this is just an example of a top-level README text file. So all a README file is a bunch of text in a .txt extension, which is just an open standard for text files. And this one is around an imaginary chemistry project. And you'll see it lists the project itself, the date, the description, the funder, the contact. It gives a bit of information about how the content is organized. It tells you a bit about the naming conventions of the different data files that are engaged in that data work. And it talks about things like storage. So these are just a few of the things that you can document in a README file that will make it so much easier for you to use your content in the future. Your memory is not going to hold as much as you wish it did 10 years, 15, 20 years from now, or even 1 year from now. And it also will make it much easier for others who come into contact with this to really understand the context in which it was created and know how to get in touch with you and know what they're using if they choose to use it. So another way to provide context for your data, and this should go hand in glove with that README file, is that you can document a data dictionary that lists and describes all of your variables. So here I'm including an example from Data 1 that from a Data 1 reference to University of Texas example. And so you'll see here that the variable and field name list in column A includes things like participant ID and enroll and F name and L name, things that maybe you would be able to figure out as a layperson or as a person in this field, or maybe you might not be able to. You've also got things like city, state, zip, sex, given birth, etc. And then you've got a form name that gives you a little bit more information about what that is. You get a section header, which in this case is blank, but then you also get a field type that tells you, is this text, is this drop down, as this question is being asked, what format is it being asked in? So this is a survey. You can read that as soon as you get to that field type. Is it a text box? Is it radio? Radio buttons, in other words. It also gives you what the field label itself is. So enroll is the variable, but the field label is really date, subject, signed, consent. That's very important to know as a researcher who either is looking back over your work years from now, or as a researcher who is coming into contact with this work and wants to be able to do something with it. So you get the picture. The data dictionary, and this is just a brief version of an example, but the data dictionary is really imperative for understanding what you mean by the different variables and field names that you provide, and to give you that context for all the different pieces of that variable. So moving on, other things that are really important in your data creation have to do with the way that you organize the data itself. So now we're moving from the documentation about the data to the way that you organize the data. So some of the principles that you'll see scattered throughout resources, this is by no means the only resource describing these, but throughout resources in the field, including many that we point to, are things like using only one variable per column, so that you know that that variable is what is creating that column. You also want to make no more than one observation per row. You want to use human readable column names wherever possible. You want to include one table per tab. So if you are using a spreadsheet and it's got multiple tabs, you want to make sure that there's no more than one table per tab. And then finally, you want to use a key that shows the relationships between the tables. And that may happen in your data dictionary. It can also happen in other ways. And so here you can see an example of data that has been organized according to some of these principles. Now, there are lots of additional principles, and I'm just highlighting a few here. So some of the things that you do want to do are consider what your null values are, what's your zero, and how are those going to be represented. You also want to consider what contextual documentation is going to be required in order to understand the data that you've created. And then finally, you want to use standard data representations wherever possible. So for example, using year to month to date. So 2018, 01/01 for January 1st, 2018. You want to use that date nomenclature. Some things that you definitely don't want to do. Don't use formatting to convey your information. So remember that formatting is one of those things that is incredibly finicky in files, and it's also not machine readable. And so when you're parsing large data sets in particular, or when you're combining different data sets together, that formatting is not going to convey information in a way that's reliable or able to be read in ways that are useful. You also don't want to place comments in cells. So if you need to make some journal entries or other comments, make sure you're doing that in a way that doesn't compromise the data set itself. You also don't want to use special characters in your field names, and you don't want to use blank spaces or symbols in column names. So these are just a few of those principles that you want to think about. And with special characters as an example, those tend to break over time. So this is not just a do not because it doesn't look good. It's a do not because it doesn't work well within a computer environment, particularly when data sets are migrated or exported. The special characters can get converted by accident by your conversion tools. And special characters will always make it much more challenging to have your data ready for interoperability with other data sets. So as I mentioned earlier, there are some discipline-specific repositories, and my expectation is that these will continue to grow, and this is only a very small number of the discipline-based data repositories that are available today. Your faculty advisors and others within your field should be able to help you identify appropriate repositories for your own data sets and databases. So here you'll have access to this both in the slideshow that is in the URL, which we'll go back over on the next slide. It's also in the guidance brief and in the handout that you have access to through this set of files. So moving on to the final slide, this is just a quick summary of some of the principles that we've discussed today. So when you are looking at data organization, there's three main issues that I hope I've gotten across. One is that decisions that you make today about how to organize and structure your data are going to have implications for how it's used in the future, both by you and by other people. I hope I've also helped you to see that different disciplines have different norms, both for structuring data and for depositing data. And so it's important to think about and to be in communion with your own field as you're choosing your data structures and your data descriptions. And then third, every data set needs both a README text file that describes the data's purpose and provides a list of the data files that are involved. And then it also needs a data dictionary that lists and describes all of the variables that you use. So I hope this has been helpful, and I wish you the best of luck.